Hello everyone, my name is Arvin Shafi and today in this video I'm going to present my coursework project for the Applied AI module. The aim of this project is to design and evaluate an artificial intelligence system that can automatically classify the genres of music using audio data based on my own decision of the topics that were provided. So my project is a music genre classification. It is a challenging task because genre often overlap and musical style is subjective rather than clearly defined. So it's one of the hard subjects. And this project, I will explore how machine learning techniques can be applied to audio signals in order to predict music genre and access how well these modules generalized beyond benchmark uh, datasets. So right here in this project, I use one of GTZen's datasets. It's not the best datasets because they're all tapped into 30 minutes soundtracks, which in this file genre data, if you look at it, you can see the different genres, and each genre has 100 of tunes in it. Each tune is 30-second mono, and it's inside these files. It's not the best file to do, but it was the only final, only data set and best data set I could find in GTZen. So yeah, that's it. I already mounted Google Drive on my uh, system, so everything is saved in here, so I don't have to upload things that I need in the project here. So quickly, let's go through the project. So for a quick explanation, I could say music genre classification plays an important role in modern music platforms such as streaming services, uh, recommendation service and digital music libraries. Accurate genre prediction can help organize large music collections and improve user experience. However, genre classification is not straightforward. As I said, many songs combine multiple styles and genre labels are often subjective or inconsistent. This makes it quite, suitable and interesting problem for applying AI techniques. For this project, as I said, I used the GTZen data, which widely uses benchmark datasets. Here, after all the explanations, I can go through the code and implementations and show you how this thing actually works. So first things first, we have a high-level diagram which I created, and the result is here. So you can see from the dataset, it loads the audio, goes to pre-processing resamples from the 22 hertz and converts them to mono, and pad trim them to 30 seconds, then clean them, harmonize them using MCFF techniques, an MCFF trained model. Uh, this goes and uses dataset and creates XY labels, splits them into trailing and validation, and then goes on with the project. You can give it new file and evaluate to see accuracy, confusion matrix predicts, and how the thing actually works. So to solve this problem, I use mel frequency, Caspro coefficients, or MFCC, as the main audio features. MFCCs are commonly used in audio and speech processing because they approximately show how humans perceive sounds. For classification, I implemented a fully connected network, FCNN. This model was chosen because it works well with fixed length features, vectors such as MFCCs completely efficient, and it's easier to interpret, uh, you know, compared to more complex architectures out there. Okay, here is another diagram which I generated using AI. It's a 3D one. So as I said, first the audio input is loaded and standardized to fixed duration and sampling rate. So each track is then split split into short overlapping segments. This allows the model to focus on local acoustic patterns rather than relying on single representations of the entire song. So MFCC features, along with their temporal diversities, are extracted from each segment. These features are then fed into the neural network, which proceeds a genre prediction for each segment. Finally, majority vote strategy is to apply across all segments of songs, produce a single genre prediction. This approach will improve, robustness and better reflects how music is structured in practice. Actually, so this is how everything works. Here you can see all the genres, and here we get to the real deal of how everything is working. So we go through the implementation here. In the implementation, the data set is loaded and proceeds to ensure all audios and all files have a consistent format. Feature extraction is performed using MFCC, and the resulting feature vectors are standardized using uh, vectors and different data sets here. Different files and dataset here. I'll import settings needed. Here we're going to load the genres. As you can see, it'll get categorized in different genres. Total files gives you a number of it here. And yeah, here it's already loaded. We can see a diagram of it. So training uses early stopping as well, but when it gets to stopping, but here is the dataset that we need for the project. This is for just unzipping the thing. So here is the main deal, feature extraction, MFCC. So in this task, it requires deploying a number of MFCC's values and updating them to extract them, the functions. So the neural network consists of multiply fully connected layers with the batch normalized and with the batch that are normalized and have dropouts. These techniques will help stabilizing and training and reducing overfitting. Here we're gonna train them with X and Y labels and giving all process to build a new feature matrix X and labels Y. So using this advanced function, this step will use the defined genres and datasets to iterate through all audio files as wrote in the description. So we need to wait for this to uh, you know does what it does, do what it does. And yeah, as well as that, for some additional explanations, I have to say training uses early stopping and learning rate scheduling to ensure that the model does not continue training once validation performance stops improving. Overall, the implementation focuses on reliability and uh, better evaluation and less complexity rather than excessive models which are pretty complex. After that, we go to testing and evaluation. But here is the training. So we split samples into training sample and test samples with new features, as you can see. And so the previous feature will extract this step completed successfully, generating new X and Y arrays with advanced MFCC statistics. So this next logical step is to split the data into training and testing sets here, as you can see. So it's kind of, if you sum them up, you get a 1,000 sum up total which is representing the number of files in the original dataset. So let me see if this is finished. Yeah, nearly. This is the FCNN models with the params, showing the layers, output shapes. So with the updated feature matrix, now we're having 300 features, 60 MFCCs times 5 statistics. So these FCNN model will input layer needs to be modified to accept the new input shape. After updating the input shape, the model will be recompleted to apply these changes. So here, this is finished. Go for the next task, which is labeling. It's done. Now here we implement the FCNN models. Done. Here we go through the training and testing. So the model is going through testing. Well, I'm going to explain how it works. So to evaluate the system, several testing methods were used. The dataset was split into training, validation, and test sets using a group splitting strategy, ensuring that segments from the same song never appear in multiple subsets. So initial experiment achieved accuracy in the range of approximately 70 to 76%, which you will see, which is consistent with expectations for MFCC-based models. After introducing segmentations, majority voting and stronger, uh, you know, regularizations, song level accuracy approach to nearly 76%, 77 in maximum, I could say, best accuracy I've ever gotten. It's not uh, it's changing whenever I do one test. So in addition, testing on GTZen dataset is also tested to the model on songs outside of the dataset, which I'll be showing you. So approximately, I could say around 7 out of 10 cases, the demonstration and reasoning is good with real world generalizations. It means that if I give it an outside sample and ask it to predict, it predicts most of them as the genre they have, but it's not very accurate at all the scenarios, obviously, because it's fully connected to the dataset. So if the dataset is very rich and have like songs that are related, like if, for example, if I give this dataset 100 songs of Michael Jackson, it's gonna predict Michael Jackson songs as it should, the genres. Here the testing is complete. Here we have our first confusion matrix. Shows our accuracy. This time is 69%. As I said, is changing every time. Here we optimize FCNN architecture again. And after that, the model has been updated with new architecture. The next step is to train optimized model using the prepared train and validation data, along with the defined callbacks, saving the best version of a new file. I have that finished. I could test the curves again. So after this, we can see the curves and the accuracy and the optimized train labels. Here is finished. Yeah, we see the loss, training validation loss, and training validation accuracy. Here again, next confusion matrix. This time the accuracy goes up to 74%. Here I have some additional stuff for hyperparameter search space, which takes like a very long time, but it finds the best trained model parameter and uses that as a prediction point and as the main model, but it's gonna take a long time, so I'll just skip this part. Here another confusion matrix shows our final best optimized models. Here you can see classification reports, best optimized models, precision, recall, F1 score, support, blues, all the genres. Here you can see the score, the recall, the precision, and the accuracy. Here you can see in the confusion matrix how many of the songs has been correctly, how many of the tracks in the dataset has been correctly, predicted as the right genre that it was. Blues is 14, 20, 40. So these are the right predicted songs. Here I'm going to just like do the testing and evaluation for the final part. First thing is, this is from the dataset. So as you can see, the address is, I don't know why my mouse is not showing, but yeah. Here you can see as I gave it the file path, it's going to go through the path here in the dataset, find one in the hip hop section, GTZen, and find one of the hip hop tracks, and it's gonna predict it. We'll see. Yeah, it's predicting it as hip hop 23%. Here I have a little jazz sound, which is here, just for showing you that is actually a real jazz sound. Into, I think, yes, Jazz Cafe background. I'll quickly just download it to show you that it's actually a real jazz sound. I think you can predict it by yourself. Here. Okay, so I think that's enough. So those who are familiar with music genres know actually this is 100% jazz pattern with that famous saxophone, and also the low tempo, uh, you know tempo. It's actually low tempo, so that tempo is not high, and it's a jazz music using all the jazz instruments. So that was the file we just looked at, Jazz Cafe background. Here you can see Jazz Cafe background. So if I predict it, you can see it's predicted as 22% jazz, as predicted genre is jazz. As for the next file, this is a rock file, metal file. Uh, what's the name of it? Stopping rock 4 shots. So if I just like find it, I think it's here. Yeah, I'm not gonna download all of them, just like this too. So that was a metal song. Prediction, rock. Yes, that's actually a rock song, so it's even better this time because that was a rock song. So yeah, metal rock. You know, it shows you different probabilities of the predictions as well, but this was definitely a rock song, as you could hear. Next one, we predicted it's a hip hop song. So it has some you know wrong predictions as well. So this one is one of the wrong predictions, but it's actually saying it's a hip hop for 9%. So it's kind of close, but it's again, it's all about the data set that you're training your models with. Here, reggaeton music. If we predict it, you see, yeah, predicts it right. It's a reggae music, very good. And the final file is it's Billie Jean from Michael Jackson. Uh, just for a So yeah, we get an error for some reason. I think, oh yeah, because the file is deleted. Okay, so the file wasn't actually saved in my dataset, so I can't really show you what's the output of this one. But I think it predicted it as pop. I think so. And disco combined. So that should be everything. So for interpretation and insights, I could say the results show that the segment-based classification significantly 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 improves robustness by reducing the impact of noisy or uh, on recursiveness and sectionized uh, parts of the parts of an audio. So the confusion matrix reveals that the model performs well on genres, and you just saw how it works, the testings, and I wasn't testing it with the models in the dataset. There were actually models outside of the dataset that shows my model works pretty well. And I could say acoustic characteristics such as classical or metal, while it struggles more with like stylistically similar genres like rock and pop. That's the way it gets confused a bit. So external testing highlights that the dataset quality has a major influence on performance, while GTZen is a useful benchmark. As I said, it does not fully represent the diversity of modern music. So about the dataset, but even with that limited dataset, you see the model works pretty fine, which limits confidence when classifying real-world audio, but still is working pretty good. For the limitations, I could say this project has several limitations. Genre labels are subjective. MFCCs do not capture long-term musical structure, and the model assumes each song belongs to a single genre. That's one of the limitations. So future work could include expanding the dataset with more diverse examples, applying data augmentations techniques, or using convolutional neural networks maybe to learn time frequency patterns directly from spectrum and the notes and the grams and tempos. So exploring multi-label classification could also be better reflect have a better reflect on the music genre overlap in practice. Okay. So in conclusion, I could say this project demonstrates that MFCC-based features combined with a fully connected neural network can achieve strong performance on music genre classification tasks, and that actually can happen, and as you saw, it happened. While accuracy is limited by dataset quality and genre, ambiguity, the system shows good generalizations and provides a solid foundation for future improvements. And I could really work on the project to just increase the accuracy from 71%, which is the average from what I got. Right now, you saw we got 77. It's changeable, but yeah, it has place for improvements. And yep, that was my project. Thanks for uh, watching this video. Hope it was good enough. And that's it. Thank you. Have a nice day.